Imagine sitting inside a spacecraft, not an ordinary spacecraft, not a rocket built by modern civilization, not something designed for the moon, not even Mars, a machine built for one purpose, to approach the ultimate speed limit of the universe, the speed of light, 299,792,458 meters per second, fast enough to circle Earth more than 7 times in a single second. At this speed, space changes, time changes, reality itself begins to distort. Because near light speed, the universe no longer behaves the way humans evolved to understand it. Stars compress, colors shift, distances collapse, time slows, and eventually you stop traveling through space and begin traveling into the future. Tonight, we are going to experience what happens at 99.999% the speed of light. From the perspective of science, from the perspective of physics, and from the perspective of the human mind. Because this is not science fiction. This is real. Human beings evolved in a world of slow speeds, walking, running, throwing. For most of human history, 20 kilometers per hour felt fast. Then came horses, ships, cars, jets. Every generation pushed faster. But even our greatest machines remain incredibly slow compared to the universe. A Formula One car reaches around 350 kilometers per hour. A modern fighter jet can exceed Mach 2. The International Space Station travels at 28,000 kilometers per hour, fast enough to circle Earth every 90 minutes. And yet, even that is insignificant, because light itself travels at nearly 1.08 billion kilometers per hour. If you could travel at light speed, you could circle Earth 7.5 times in 1 second, reach the Moon in 1.3 seconds, reach Mars in minutes, reach Jupiter in under an hour, and cross the entire solar system in less than a day. The scale is almost impossible for the human brain to truly comprehend. But the deeper mystery is not how fast light is. The deeper mystery is what happens when something with mass tries to approach it. In 1905, a young patent clerk named Albert Einstein published a paper that would permanently change human civilization: special relativity. At the center of this theory was a shocking realization. The speed of light is always constant, no matter who measures it, no matter how fast they are moving. This sounds simple, but it breaks common sense. Because if light's speed never changes, then space and time themselves must change instead. This was the birth of space-time, a universe where time is not absolute, where motion changes reality, where clocks can tick differently depending on speed, and where the future can arrive faster for one person than another. You enter the spacecraft, the engines activate, acceleration begins. At first, everything feels normal. Earth slowly shrinks behind you. The moon becomes distant. The planets drift apart. But as your speed increases, physics begins to reveal its hidden nature. At 10% the speed of light, nothing dramatic appears visually. But the energy required to continue accelerating becomes enormous. Because unlike ordinary speeds, relativistic speeds demand exponentially more energy. The closer you get to light speed, the harder each additional increase becomes. To push a massive spacecraft near light speed, you would need energy comparable to civilizations, entire planets, perhaps stars. This is one reason interstellar travel is so difficult. Not because the universe is impossible, but because physics is brutally expensive. At higher speeds, you begin noticing something strange. The universe changes color. Ahead of your spacecraft, light compresses into shorter wavelengths. This is called blue shift. Behind you, light stretches into longer wavelengths. This is red shift. The stars in front of you become brighter, bluer, and more energetic. Behind you, the universe darkens. Eventually, visible stars disappear into infrared. The cosmos itself transforms around your motion, and this is only the beginning. At 50% light speed, time itself begins changing. Not as an illusion, not because clocks malfunction, but because reality literally behaves differently. This phenomenon is called time dilation. Inside your spacecraft, you feel completely normal. Your heartbeat feels normal. Your thoughts feel normal. Your biological processes continue normally. But to observers on Earth, your clock is slowing down. This sounds impossible, yet it has already been experimentally proven. Atomic clocks aboard aircraft, satellites, and spacecraft all experience measurable time dilation. Even GPS systems must correct for relativity every day. Without Einstein's equations, modern navigation would fail. Relativity is not theory anymore, it is engineering reality. Imagine two identical twins. One remains on Earth, the other travels near light speed. Years pass. The traveler returns, but something horrifying has happened. The traveler may have aged only a few years. While decades passed on Earth, their sibling is now elderly, perhaps gone. Entire generations may have lived and died. The traveler effectively moved into the future. This is not fiction. This is a real prediction of relativity, and every experiment humanity has conducted supports it. Near light speed, time itself becomes flexible. As your velocity increases further, space itself begins changing. From your perspective, distances shrink. This effect is called length contraction. The faster you move, the shorter distances become in your direction of travel. To outside observers, a distant star may still be 4 light-years away, but to you, that distance becomes compressed. The universe itself folds inward. This creates one of the strangest consequences in physics. Interstellar travel becomes possible within a human lifetime, not because you exceeded light speed, but because space-time changed around you. At sufficiently high velocities, a journey that appears impossible from Earth may feel achievable to the traveler. At 90% the speed of light, reality begins collapsing into extremes. Time dilation becomes dramatic. 1 year for you may equal multiple years for Earth. Stars ahead become compressed into a brilliant tunnel of light. The sky behind fades darker. The universe appears concentrated forward. Radiation intensifies. Tiny particles become dangerous. At these speeds, a microscopic dust grain can strike with explosive energy. Interstellar space is no longer empty. It becomes a minefield. Every atom becomes a projectile. Every collision carries catastrophic power. Protecting a spacecraft near light speed may require magnetic shields, plasma barriers, or technologies humanity has not yet invented. Why can't humanity simply build a light-speed ship today? Because nature demands a price. The closer mass approaches light speed, the more energy it requires. And as you get nearer and nearer to light speed, the required energy approaches infinity, which means, according to current physics, objects with mass cannot actually reach light speed. Only massless particles, like photons, can naturally travel at c. This is why light speed is considered the ultimate cosmic speed limit, a barrier built into space-time itself. To even approach it, a civilization may require technologies beyond modern comprehension. Fusion propulsion, antimatter engines, laser-driven light sails, gigantic energy infrastructures in space, perhaps entire stellar economies. Interstellar civilizations may not simply build rockets, they may build civilizations optimized for energy production. At 99% the speed of light, time distortion becomes extraordinary. The cosmic microwave background, left over from the birth of the universe itself, shifts into visible light. Space becomes luminous, reality becomes violent. Every hydrogen atom in interstellar space slams into your spacecraft with enormous energy. The front of the ship may glow from constant particle bombardment. Your environment becomes closer to a particle accelerator than normal space. Yet inside the spacecraft, you still feel ordinary. You eat, sleep, talk, think. Human consciousness remains trapped inside a relativistic bubble while the external universe races forward. Now imagine traveling at 99.99% light speed for what feels like 5 years. When you return to Earth, centuries may have passed. Civilizations may have risen and fallen. Languages changed, borders disappeared, technology transformed beyond recognition. You left Earth as a human from one era and returned as a visitor from the past. This is the true emotional consequence of relativistic travel. Interstellar explorers may sacrifice connection with their own civilization. Every mission becomes one way through time. The stars are not merely distant in space, they are distant in time. What would your eyes actually witness near light speed? The answer is deeply strange, because light itself would distort around you. The forward universe would appear concentrated into a bright circular region. This is caused by relativistic aberration. Stars from the sides would appear pulled forward. The universe behind you would compress into darkness. Brightness would intensify ahead, potentially becoming deadly. Some physicists believe the front view could become flooded with high-energy radiation. Your spacecraft might require artificial shielding just to survive the light itself. Near light speed, Vision stops behaving normally. Reality itself bends around motion. Could humanity ever truly travel near light speed? Perhaps, but not with chemical rockets. Modern rockets are astonishing achievements, yet they are primitive compared to the demands of interstellar travel. To approach relativistic speeds, future civilizations may require entirely new propulsion systems, fusion drives, antimatter propulsion, beamed energy systems, interstellar laser arrays, massive space infrastructure, perhaps even physics humanity has not yet discovered. The challenge is not only engineering, it is civilization-scale energy production. Because deep space travel is fundamentally an energy problem, and mastering energy may define the future of intelligent life. If relativistic travel is possible, then where is everybody? Why does the universe appear silent? This is known as the Fermi paradox. A universe billions of years old should contain civilizations far older than humanity. Some may have mastered relativistic travel long ago. Some may already spread across galaxies, yet we see nothing. Perhaps interstellar travel is too difficult. Perhaps civilizations destroy themselves, or perhaps the distances and timescales of the universe isolate intelligent species forever. The silence of the cosmos may itself contain an answer. Imagine the loneliness. You leave Earth knowing everyone you love will age faster than you. Every mission becomes separation from history itself. Children become ancestors, cities become ruins, humanity evolves without you. Relativistic travelers may become temporal refugees, disconnected from the flow of civilization. Near light speed, space travel becomes psychological travel, not only across distance, but across eras. The deeper humanity studies physics, the stranger reality becomes. Quantum mechanics breaks intuition, black holes break space-time, relativity breaks time itself. The universe does not operate according to human common sense, because human intuition evolved for survival on Earth, not for understanding cosmic reality. Near light speed, we encounter a universe far beyond biological intuition, a universe where time bends, distances collapse, and causality itself becomes fragile. One day, humanity may leave Earth, cities may orbit stars, artificial worlds may drift through interstellar darkness, future civilizations may cross distances we currently consider impossible. And somewhere, far beyond our era, travelers may already move near light speed, watching galaxies evolve, crossing cosmic oceans, experiencing centuries while living only years. Perhaps the destiny of intelligence is not to remain on planets, but to master space-time itself, to become a civilization that lives among stars. Yet no matter how advanced humanity becomes, the speed of light will remain one of the universe's greatest boundaries, a reminder that reality has rules, and that even the most powerful civilizations must obey the architecture of space-time. Because near light speed, the universe stops feeling like a place and starts feeling like time itself. If humanity ever reaches these speeds, astronauts may leave Earth for a single mission, only to return to a completely different civilization. Near light speed, space travel becomes time travel, and perhaps one day, somewhere in the distant future, a human being will look back at Earth from another star system and realize they have traveled not only across space, but across history itself.